Well, then we gotta get that equation in quick. You're 6.5 minutes into class. Alright, the timer is up. As soon as I get the table on the board, we're starting. So get your equation in. As soon as I get the table up here, we're starting. What did the x start with? Negative 30?
36.
Negative 6?
Negative
36? And then negative 30?
And then 24, 18.
And then what did the y start at?
34, 25, 16, 7,
Alright, so let's look at this. First off, we have a few different things going on that we need to address. One, make sure you silence your phones. Two, okay, we need to look at this problem again.
Here's one.
Alright, so, I cannot emphasize this enough. Okay. A lot of us are definitely recognizing the type of function. Finally, we're getting there. What type of function are we dealing with? How do we know this is linear? And it's not just repeated addition, it's constant addition. Remember, what other type of function has a repeated additive rate of change? Quadratic is just not constant, it is... What type of rate of change was that quadratic? Linear additive? Yep, that one, Woo! Alright, so what's happening to my y values?
It gets subtracted by 9.
Minus 9? Is that all I need if it's a linear function?
No.
I also need to look at the x.
It's plus 6.
Plus 6. Now that we know rate of change, we know the type of function, which means we should immediately know what equation, what formula we're going to use here.
Y equals mx plus b, or y equals a plus bx.
Okay, you've got to know your equations. I'm going to pass back our Venn diagrams and the first understanding check today. We're going to talk about a couple of key details, but I'll do that in a second. But we should know that equation as soon as we see this, and we should think through something. Now, I heard Cam ask a question. I need to emphasize and remind you of this. What is understood to happen between that m and that x? It's understood to be multiplication. Tevin, why is it important? First off, iPad up right now. Why is it important that there's multiplication between that m and that x? Do you know, Tevin? Okay, we need to pay attention to this. These equations are not random, right? Jose, why is there an understood multiplication here?
Because I'm still multiplying a little between.
But why is that important for a linear function?
Because it's constantly adding, which is multiplication.
All right, remember, multiplication is constant addition, repeated addition. And because that linear function is repeatedly adding, we have multiplication there. We have to have multiplication, Cam. Right? The calculator doesn't make a mistake with that. We have to have that multiplication. All right? It's that constant additive rate of change. But it's not just repeatedly adding. We have a starting value, which is why I do like the a plus bx. I know y'all are more familiar with this, so I usually use this. I like this one a little bit better. But how do I calculate that slope? This is something that a lot of y'all are forgetting here. How do I calculate that slope? Little triangle thing, that Greek letter delta. Can someone at the door? Is that my imagination? Okay. The change in y, remember that's my rise, divided by change in x. Okay. And by the way, I do want to point this out. Earlier I did hear Grace say change in y over change in x, and I corrected her, and she said I'm sorry. And I'm like, guys, I'm not correcting you to make you feel better or anything like that. I'm just trying to help you get better. When I correct you, it's not, and I asked you, and what I said was, can you say that again, right? To remind you, change in y divided by change in x. I'm not getting on to you. I'm just trying to help reinforce better mathematical language, right? I'm not upset about that. I just want you to develop better habits. And so when I remind you or I correct you, please understand that. It's not like I'm upset. I just want you to get better moving forward. It's about the growth. So, change in y.
Oh.
-9 divided by
6.
6 gives me -3/2. Now, my b, 34, right? Is b 34? I don't see anyone to put that over there.
No.
No.
Why not?
Because it ain't 8, 0.
Okay.
He is right intercept.
Alright. By the way, I do want to remind you all this. This is an important detail that I don't use this language a lot, and it's important. What is the name of this equation of a line? Because there's other equations. Slope, intercept, right? It's not random, it's because we have a slope and we have a y-intercept. Even here, I have a slope, right? Multiplication is repeated addition, slope, intercept, right? So, you said I need an x value of 0. So what am I going to do to get that?
Keep going.
Keep it going, right?
It is.
That gives me a -6.
Okay.
That gives me -11. Add 6 once more. -9 once more, and I get -20. Or, we're saying that we're starting at -20 and subtracting 3/2 x. Or 3/2 x number of times. Either one of those works. When are we going to have a test on finalizing this information?
Friday.
Friday. We've got to study this. We got to know this. We've been working on writing equations of linear and exponential functions in this class for about 3 weeks now. And you've been doing linear equations since 8th grade. Should have done linear and exponential in Algebra 1. So we got to know this. We got to know how to do this stuff. Alright, so what are your questions before we continue with today? Going once. Going twice. Sold. Alright, so let's look at our agenda. Alright, so I have a reminder here to myself to pass out papers. Don't let me forget to pass out the understanding check. But before I pass out I'm going to pass out understanding check later today. Tevin, Trayana, Miracle, Jalen. Should have done this while y'all are doing the bell ringer. Sorry for wasting time. Preston is there. Cam. Jayla. Huh? There we go. Oh. And the higher score is the correct one. You just gave me 2, and so I ended up scoring them both. Shania, Grace, Lily Kate, Sanaya. You gave me 2, so whatever the higher one is the correct score. Ethan, Phoebe, David, Eliza, and Marshall, Eliza, Jamarcus, Jose, no name, is it? Rakai, where is it? There you go. Naisha. And Jacoby. Alright. Is that one yours? Okay. So remind me so I can put the score in later. Alright, so 2 quick things about this. Please listen up. Okay? The point of these Venn diagrams was that you have something to study and base your overall understanding on. If I were you, I would make sure I update this before your test on Friday. Now, this is not a 15-point assignment because that would be way too many points in comparison to understanding checks, things like that. Your actual score will be divided by 3. So take your score divided by 3 and it'll be out of 5 instead of out of 15. That's more representative of what it should be. Now, once again, I cannot emphasize this enough. I would update this before your understanding check on Friday. And most of us need to update it not by Googling things, but by looking at our notes, not by copying things, from other people, but by looking at our notes. We covered, and I would probably write this down to myself, we covered all of these major concepts with the dream job salary task, so that you know what to go back and look at. That was the dream job salary task and the gold rush task. All of your information should be on those tasks. Okay? Let's say you don't have that information. Anyone know where you can go get some of that information pretty easily? Go to YouTube. Let's go see what days we covered those concepts. Alright, so if I go to YouTube, I know it's at the end of January. Let's see, to use or not to use. Here's gold rush. Linear versus exponential. So January 25th, January 26th, and January 30th is where you should be looking. Actually, January 24th through 26th. January 24th to 26th. All the information is there on YouTube. If you need updated information, I would go there. There is also a whole lot more that we know about quadratic functions at this point. So we can add that in. I tried to note where you have, if you have a 2 out of 3 that's not random, there's probably 3 major things that I'm looking for. And when we talk about a linear function, we should have constant additive rates of change in tables. We should have linear, or lines on graphs, and we should have an equation that we've explained. 3 major things. Explain what those parts are, right? That's where those are coming from. And so if there was 2 major things I was looking for, then something out of 2. Okay? So look at that. It's not random. If you're missing points, it's because you are missing something, and that something is important for your understanding. Now, last thing I'm going to talk about with this Venn diagram before we get started with today is this. This is just an example, but I saw a lot of people tell me a quadratic function has a linear additive rate of change. Is that true? Yes, Mr. Kenny? Great job, guys. That's 100% truth. However, is that going to help you when it comes to identifying that quadratic? Some of us, yes, but not everybody. Do you have an example of a quadratic function somewhere that you could show the table and show that linear additive rate of change? 100%. You could go back to the gold rush task, where we had the base of the rectangle, we had the area of the rectangle, and it was 0, 5, 10, 15, 20, 25, and it continued. And we had an area of 0, we had an area of 225, 400, 15 times 35 was 525, 600, 625, right? And we showed the fact that there was a linear additive, 125. And then we said, so this is plus 50, plus 50, plus 50. This is what a lot of us were missing on the understanding checks as well. This is constant additive. So, what is the rate of change? Was always to the left of constant additive. Always to the left of constant additive. Linear. So this is a linear additive rate of change. And what is to the left of a linear additive rate of change? Quadratic. What's going to help you study better, just saying this, giving an example like this. The whole point of this is for you to go back through your notes to see what information you have, and if you don't have those notes, to go look at YouTube, where I have literally recorded these things in class. Yes, Miracle. Not Miracle, Haley, sorry. Literally, if you search my name, it's the first one that pops up. So if you search Nathan Kenny, it will pop up. I've tested it out multiple times. Okay. So, please understand, guys, the more detail you have, the better notes you're going to have to study off of. Even if you earned a 3 out of 3 because you hit every detail, go in and add extra details. These are the things that you should be thinking about to understand these different types of functions. What are your questions at this point before we continue? All right, we need our textbook out. I am going to pass out your first understanding check before the end of class. I'm going to do that while y'all are working in your small groups. So we need to have our textbook out. If I remember correctly, we already finished this graphic organizer on pages 73 through 75? Yes? Okay. So we're going to be able to jump down to here. I believe we're on activity 4.2. Which is somewhere around page 61. I'll get there in a second.
It's 57.
It's 57?
Yeah.
Thanks, sir. So we're on M1-57. Right, but I'm going to do a quick small recap, and then we're going to move into the next one, okay? All right. So, can I get somebody to read our objective for us to get us started with today? I know it's really scary reading an objective off the board. Thank you, Lily Kate.
I can identify the features of a parabola based on the form of a quadratic equation.
So remember, you can always see those features on the graph. We aren't going to be graphing, and I need you to hear me clearly on this. When it comes to the understanding check and test, there will be non-calculator portions. Because I don't want you to just plug the equation into a calculator and look at the graph and know what the features are. I want you to be able to look at that equation and figure out the features just from the equation. This is an algebra class. We use the graph and Desmos to explore and see how the equation connects to those features. But we need to move to a more abstracted version of this to understand those features. Now, what are the features that we are going to be looking at, or that we are looking at? Concavity. What else? X and Y intercepts. Do not forget your X and Y intercepts. What did you say, Phoebe?
The vertex.
The vertex. What else? And the line of symmetry. Those are your features that you have to be able to quickly identify. And so, as a quick recap, which features can you quickly see in standard form? Right, if we have that ax squared plus bx plus c. The y-intercept and concavity. We got to know which part of that equation tells us those things as well. So you have to know this equation. You have to know what part tells you y-intercept and what part tells you concavity. And we should have notes about that. The Desmos activity, this here, we should have those notes everywhere. What about factored form? What do we see in that factored form? X-intercepts and concavity. Right? X-intercepts and concavity, very quickly seen in factored form. And in vertex form. Vertex, right? Huh? Line of symmetry and concavity, right? So we're always going to see that concavity from A very quickly. Now, I will point this out. Can we still find those other features?
Yes.
We can. It's just not going to be as quick. Because what do we know about every y-intercept? So let's go ahead and go here. What do we know about every y-intercept that has ever existed? So I can substitute that 0 in for x. Z, what do we know about every x-intercept that has ever existed? Z, but what did you say? You're good. Z, do you know? Okay, so when you pay attention, Jayla, do you know?
What was the question again?
What do we know about every x-intercept that has ever existed?
Is it R1 and R2?
So those are our roots, and that's what we're going to see in the factored form. Tevin? Very, very close. Let's focus on that language. He said y-intercept is always going to be 0. But I'm looking at the x-intercept. What does he mean? David?
The y going to be 0.
The y value, right? Remember, the y-intercept is when the relation intersects the y-axis, Tevin. but there's always x and y values. I'm only looking at the x-intercept. So z, what do we know about that y value for an x-intercept? The y value is going to be 0 all day, every day. And so I can substitute 0 in for y and figure out what x is. And then the last thing I would remind you is this sheet right here about Christine and Kate. This was to help us figure out how to determine the vertex and the axis of symmetry, even if we have standard form or factored form. Now, you may think, hey, Mr. Kenny, I'm going to have a calculator to be able to do those calculations. I promise you, it'll be really nice, easy numbers. And if you need help with a calculation during the understanding check, because you don't have a calculator, come up to me. As long as I'll tell you, I won't tell you if you get the answer right or wrong, but if you come up to me and say, hey, Mr. Kenny, what does this become? I'll tell you, oh, that becomes -3. I'm not going to tell you if it's right or wrong, but I'll tell you what that would simplify to if you need that help. Yes, ma'am?
So when is the understanding check?
Tomorrow. Yep. Understanding checks tomorrow because the test is on Friday.
Well, I ain't know all that.
Know what?
We had it for-
Oh, that's weird, because I thought we were supposed to have an understanding check today, and I told you all that, and I moved it to tomorrow.
I thought you said Thursday.
No, the test was supposed to be on Thursday, and I moved everything back a day.
I thought you said
What if, so you know how you gotta understand shit, like, you gotta go over it and take tests, right? Like, you study for the test.
I mean, I go over to help you study for the test,
Okay,
yes.
what if you can't go over, like, what if you're not there on the day that you get it back? That you do something.
Well, I'm giving it to you tomorrow, and we're gonna go over it immediately.
What did I
I'm gonna take it and score it, but what I'll probably do is I'll probably scan it during class, so I can give it back to you immediately and score it later, okay?
It's not right.
So your notes will help you there. Alright, so here's where we are now.
Get smart.
Quick recap of everything. We're on activity 4.2. Now looking at this activity 4.2, this is that M1-57 that Jamarcus helped us out with. Jamarcus, you not have your book today?
She needed it.
Oh, Jayla's just trying to steal Jamarcus's book. Alright, remember, yesterday we did this part already, and we started by looking at each equation to figure out if it could go with that graph, right? And so how did we determine if the equation could go with the graph for part A? Huh? The key features, right? When we have factored form, what feature do we look for? X-intercepts and concavity, right? If you don't know your equations well yet, this is a great time to look at your notes and write the equation above it. Because if you write the equation above it, one, it's going to help you remember that equation better. Every time you write it, you'll remember it better. Two, it's going to help you identify those features. Here is A. A is less than 0, so the parabola is concave down, right? Okay, it's x plus 1, but it's supposed to be x minus r1, so r1 has to be a -1. r2 had to be a -4. So I have these x-intercepts. And someone asked yesterday, and I should have clarified this, they're like, well, Mr. Kenny, how do I know if it goes with that graph? There's no numbers. But what do we know about these x-intercepts? They're what kind of numbers? Negative. So we have negative x-intercepts. That's all that you have to do is, could it go there, right? And so that's how we knew f1 of x could go with that graph. And so we want to think through those things, we want to identify, we're going to talk through them more. And I believe, did we start on number 1 yesterday? Or, sorry, not number 1, part B here yesterday? We just didn't finish? We started, but we didn't finish, okay? So let's do this. I'm going to give you all about 5-6 minutes to finish looking through part B before we move on. And so what I want you to do is same as yesterday. I've identified who works on which vertical surfaces. I want you to write out the equations, the equations that could go with that graph. Now, to make your job easier, remember all I'm asking you to do is, if you think f1 of x works, then maybe just do something like this, works, and just write f1 of x. And then doesn't work, maybe f5 of x, right? Just write that out to indicate which functions could or couldn't work. Be ready to have a conversation and explain it and get off your watches. Be ready to have that conversation and explain it, but you don't have to write it down for now. You don't have to write out the entire equation, but be ready to talk about it. Does that make sense? Questions? We know what we're trying to do now. Okay? Miracle, sorry for not turning on the TV. Go ahead and turn it on the TV. Alright, let's go ahead and start sorting or identifying which could and could not work. If you want to stay seated, cool, but we need to get our answers on the board, so let's get to work. Yeah. This one got angry and ripped book. Come on, Shania. Wake up. Dang it, I even brought rags and I settle the debate just amongst yourselves, then bring me over. And when I came over and we wrapped up that discussion, do we understand the concept better with F5, right? So engage in that conversation a little bit. All right, so F1 of x works for everybody across the board. Everyone said F1 of x works? Okay, so what do we see in F1 of x that tells us it works? Did we talk about this one, didn't we?
No.
No, we didn't?
No, we didn't.
Okay.
Okay.
All right, we didn't talk about any of them. All right. Huh?
We did talk about it first.
Oh, but yes, we did.
No, we didn't talk about the.
We just erased it.
It was, I was like, I did it before y'all started, right? Okay, so we're good on F1 of x. All right, so F2 of x. No here, no, 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 and no. Okay, so what in F2 of x tells us no that it does not work? We have one group who said concave down for F2 of x.
It ain't no concave.
Say that one more time. There's no concavity at all?
No, it is. It's just,
I just
it's square.
So let's talk about it. This is hold on, this is a good point. Listen guys, if I have a parabola, it has to either be concave up or concave down. David, what you got?
Would it be understood to be a zero? Or something like that?
If I have a 0 here, what is 0 times anything?
Zero.
So can it be a 0 here? It's an understood 1, okay?
I knew it was something.
Right, so if it's a plus, guys, hey listen, if there's nothing written, it could be an understood plus 0, or it could be an understood times 1. Now notice, right, it's not, is that positive or negative? So it would be concave up. Okay, so does that feature, does that concavity match the graph?
Yes.
Yes, and I would note that, right? I would have, okay, concave up, that works, but then we are looking at what feature of the parabola because it's factored form?
All one or two.
So the roots, right?
Yeah.
Do those roots work?
No.
Neither of them work?
No, one of them do work.
So 8 comma 0 could work,
Yeah,
but
that one don't.
that could not. As soon as we know that one feature does not work, we're done. F2 is out. Questions about F2? Feeling better?
Yes, sir.
I'm not offended.
Yes, mister.
There we go. Alright, so F3 of x works. Oh, and so F2, so F3 works. Do I have F3 working back there? Yes, okay. So, concave down, is that true? Remember guys, especially if I'm struggling to remember the equation, we should at least recognize standards, write that equation above, so what is my A value? A, so A is, well, no. A is greater than 0, so it's concave up. Be careful, right? The concavity is up or down, depending on if A is positive or negative. Okay, Jay, it looks like you have a question about that. Okay. Is that starting to make sense, the concavity though? Okay. Go for it. What 0? This 0? This 0? Okay. Can y'all tell us where you got this 0 from right here? Huh? The C? Okay, so in standard form, that C is the y-intercept. And tell me this, Triana, what do we know about every y-intercept that has ever existed? Do you know? X is 0. That's where it's coming from. Notice, and guys, it's not just random. If I substitute 0 in, right? So F3 of 0, I'm substituting 0 in for, what was this originally? What did that 0 just take the place of? X. Remember how it was F3 of X?
Oh, I'm sorry.
You're good. Substituting that in for X, minus 88 times 0 plus 240. What's that going to become? That's 0, isn't it? What's that going to become? So I get 0 minus 0 plus 240. So when the input is 0, the output is. But I don't have to do all that work because it's in standard form. I automatically know that y-intercept. Does that make sense, Chandler? Okay. And so that's why that constant is my y-intercept, because everything else would become 0 when I substitute 0 in. Okay? Now, I do want to point this out. Personally, I'm always going to check vertex 1 because it's a good habit. 2, because we need practice. How do we calculate the axis of symmetry, the x value of the vertex, based on standard form? Negative b. Then what? Remember, this is that axis of symmetry from standard form. I would check this. It's going to help. So what is b? Huh? 88? Close. Remember how it's plus b, so I need to keep the sign the same. So
negative 88.
negative 88. B is negative 88, right? But I want the opposite of b. So what's the opposite of a negative 88? Positive 88. Divided by what? 2 times 8. A is 8, isn't it? Now, I'm not going to give you anything that's complicated on the understanding check, but this is something that you can do. Notice 88 divided by 8, that would give me 11. I'm not going to give you this complicated because you're not going to have calculators, but that gives me 11 divided by 2, which is 5.5. More importantly, is that positive or negative?
Positive.
Is this to the right indicating that x is a positive value for that vertex?
Yeah.
Yes. Okay. So I'm going to check that as well. Standard form is one of those tricky ones where the y-intercept could be correct, the concavity could be correct, but the vertex might not be. So you do want to pay attention to that. That would be a good note to take about that vertex if you have not already for that problem, or that axis of symmetry at least. Okay. F4 of x, across the room I'm seeing that it does not work. What feature for the fourth function does not work? Concavity, right? A is less than 0, so it is concave down. Does that match the graph? Nope. That's what the issue is. Do the x-intercepts work? Those roots? Yeah. The roots would work, but the concavity does not. Okay. For the most part around the room, I see F5 as working, except for group 5. Y'all said it does. Wait. F5 does not work? Oh. So we need to update that, right? No to F5? It's concave down. We all good with that? That the parabola would be concave down because A is negative 2? Notice, does the vertex work? Just because the vertex works does not mean the whole function works, though. Yes, ma'am. What questions do we have through number 5 at this point, or equation 5 at this point? All right. None? Going once? Going twice? So F6. Across the board, I see we're saying that F6 does not work. It does not. What feature of the 6 function does not work? Look at F6. Do we have roots here?
R1. No, I'm sure my bad.
What form is this? Standard. So I should be looking at a y. The y-intercept does not work. Is it concave down though?
Concave up.
Notice how many x squareds do we have? 1. It's an understood 1. So a is positive, so it's a concave up parabola. Alright, what about f7 of x? No? So no. Now group 6, you said f7 does work. Why would you think that group 7 does, or f7 does work?
I think we're just looking at the concavity.
Okay. So the concavity, does the concavity work for f7? Yes. Okay. What's the issue with the 7th function though? The k value is the problem?
And
What does k equal in this function? -2? Is that a problem actually?
no,
K being -2 just means it goes
down.
down. Did that go down?
Yeah, but
So k is not the problem.
H.
H would be a -4. Don't forget, it's x minus r1, it's x minus r2, it's x minus h, so I always need the opposites. There we go. There we go. So notice, remember, h and k, that tells me about the what feature? The x and y of the what? Vertex, right? We want to put the h and k together for that vertex, right? That's not the x and y intercepts. Is that what you're going to say?
No, it's not.
Okay, so making sure. Remember, it's vertex form. There's my vertex. This is the problem. That does not work. Also, I have my line of symmetry. What would the equation be for the line of symmetry here? X equals what? Not 4. Remember, x is equal to h, and h is, right? X is equal to h, so it would be a -4. Right? Because it has, is that what you say again, Ethan? Okay. Be careful though, because we do need that negative. X equals 4 would work, because it would be to the right. Here it would be x equals -4 to the left, and that would not match that parabola. And then finally with F8, what's the problem? Because we all said no. The roots. When we have roots, we always need the opposite. So R1 would equal -1, R2 would equal, and do we have negative roots here? No. So neither of those would work. Do notice we still have concavity, but the concavity would be up, right? A is 1, concave up. The concavity would work, the roots would not.
We're the only group.
Congratulations, it's not just about that.
Well, I wasn't sure, because like I didn't know what was happening throughout any of that.
Well, apparently we learned something.
Yeah.
Yep. All right, so let's move to part C. Oh, actually, what are your questions before we continue to part C? Hopefully we're starting to make sense out of this. All right, let's move to part C. We'll come back together in about 5 minutes. All right, there's only 6 equations there. We should have some better understanding. Move to part C. And then put your answers on the board. So if you want to go ahead and start putting your answers on the board, go for it.
I was doing technical form that we just did.
Yeah, just like you just did.
What do you have against your birthday?
K is
Anyway,
Jalen, how you feeling? Still bad?
or
Okay, we need to go.
Yeah. Yeah. We worked on it all the time. You were out a lot last week. I was saying, you still need to get it done. Remind me of that when you finish. Thank you. Thank you. All right, so let's look at these 6. So we're saying F1. So I have here F1 works, F1
It's the
doesn't.
wrong one.
I'll leave it that one.
Look at the orange.
Okay, so erase this?
Yeah.
Yes.
Okay, so F1 does not work. Does not work, does not work. Okay, so F1 doesn't work. What's the issue with F1?
R1.
R1? You sure R1's the only issue? What is R1, by the way?
Negative
-1.
1.
What's R2?
So positive 1.
I want you to look at that graph again. Is it just R1 that is a problem?
And the A.
Why do both of them not work? Hey guys, we need to listen to what Jacoby just said because we're missing a key detail. Say again.
5 is not negative.
No, the phone would be.
That's not the issue. Huh?
The phone would be under this. Like,
Okay, Jacoby, say what you said again.
I would be honest.
The graph's not, it's not the y-axis, it never intersects the x-axis. Shai, look at it. Does this ever actually intersect the x-axis? So it doesn't have a negative or a positive root. Okay? It still has roots, and we're going to talk about that next unit. But those roots are called imaginary roots, and we're going to discuss what that means next unit, okay? So we need to recognize there's no real roots. No real roots, right? It never intersects the x-axis. Does anyone know what other function that would immediately tell us doesn't work? Right? No real roots, it never intersects the x-axis. Which other function could not work then? F4. We don't have any roots, do we? Or real roots. Same as f1 of x. Okay, so it's a pretty quick thing to eliminate. You cannot have factored form yet if it does not intersect the x-axis, because remember, that's giving those roots give us our x-intercepts. Right? Those roots give us the x-intercepts. F2 though, said also doesn't work. Okay? What's the issue with F2 of x? K and H?
Yeah.
Okay, so remember it comes together as H comma K, so that's our vertex. What is the vertex here?
Negative 5, negative 6.
Very close.
Negative 6, 6, 5.
Oh.
Because remember, H
Oh, you right, I'm sure.
and K,
I'm sure.
right? Okay, negative 6 comma negative 5, neither of those work. That would be, by the way, what quadrant would this be in?
Oh,
Remember, 1, 2, 3, 4.
quadrant 4? No,
Three.
quadrant 3.
Going to the left and down, it being quadrant.
You're not tripping.
3.
Just in there.
The vertex is in quadrant 1. Okay. F3 of x. We all said it works. Concave up. Right? Concave up, y-intercept is 0, 10,010. Okay? Which is why. Alright. F5, we said it does work.
You said who?
F5 does work.
Yeah.
Up, concave up.
H2.
And 6, 5 would work. Right? And did we say F6 does not work? Why does F6 not work? The y-intercept would be 0, comma, -5, okay? Now, please hear me very clearly, right? That's the issue. Please hear me very clearly. The whole point, or not the whole point, what I want us to recognize is we need to, what's the word I'm looking for? We need to know what form of the quadratic equation we're looking at. If you don't know the form, it's going to be hard to identify the features. So when I look at f6, as soon as I look at f6 of x, I know that that's what form? Standard form. Practice writing out your standard form above it, because it's going to help you identify a, b, and c. A is what is in front of the coefficient of the x squared, so it's an understood 1. B is a 2. C is a -5. And I'll point this out, and this is important here. C is not the only problem with f6. It's not quick and easy to see, but what other feature can I find from that standard form that's important? So, could I find the line of symmetry? How do I calculate that line of symmetry from standard form? X equals -b divided by 2a. So b is a 2. What's the opposite of 2? -2. Divided by 2 times, what is a? 1. So -2 divided by 2, which would be? -1. That is something that I might give you on an understanding check and expect you to be able to simplify and get that -1. Now, we'll also point this out. With my scoring system, can you make a small procedural error and still show me strong understanding?
Yeah.
Yes. I literally account for that. I'm looking for clear evidence of your understanding. So even if you make a procedural error in identifying something like that, you can still earn credit pretty well. Now, that's also my h value. Does anyone remember how I could find my k from here? That's h, right? Because x equals h. How would I find k? Say again. What am I going to distribute? Remember, once you find the x value of your vertex, there's one thing you're always going to do. You're going to substitute it in. Remember, h, that x value, is my input. Good job, guys. Input. So I'm going to substitute it in. Now, you need to make sure that you recognize x is being squared. So I'm going to put -1 inside of parentheses before I square it. 2 times -1 with those parentheses. And this is important, because -1 squared, what does it mean to square something? Multiply it by itself. So what's -1 times -1? A positive 1. This is a time where if you set this up, guys, and you're not 100% sure how it simplifies, you can come and ask me. But again, even if you make a procedural error, if I see that you understand what you're doing, you'll be okay. 2 times -1 would be -2, -5. f6 of -1 would be -6. So I have a vertex of -1, comma, -6. Okay. Now, I'm not going to go into a whole lot of detail with the next two problems. I do want to briefly touch on it though, but we're going to come back to it actually within our next unit. But I want to point this out. Right now, I had standard form, right? Based on the fact that I now know my vertex, could I write that equation in a different form? I'm going to tell you yes. Which form could I write it? Vertex form, right? I know my vertex form is what? What is vertex form? We need to know this off the top of our head. A,
Comma, x minus h.
parentheses.
My bad.
You get it. X minus h. I have A, I have H, and I have K. What is A from the standard form? What is a from that standard form?
One.
Remember, x squared is x squared. A is just the coefficient. So a is a 1 times x minus,
Well, plus one.
okay, I was say, right? It's subtracting h, so minus a negative 1. We have our h here, we have our k, that's our vertex. So when I subtract a negative, it becomes a positive 1 squared
Plus negative two.
plus negative 6. But what's the more common way to add a negative?
Subtract.
Just subtract. Once you identify that vertex, you can convert it to another form. And this is going to be important within our next unit because I told y'all this yesterday, I believe. If I wanted the x-intercepts, what do we know the y value is? So don't write this part down, but if I wanted the x-intercepts, what do I know the y is? The y value is always 0 for those x-intercepts. Do you know how to solve this equation? And you might say, well, I'm going to add 5 and I might subtract 2x. I'm going to go ahead and tell you right here. X squared plus 2x, because we have that variable x showing up twice, and one's being squared, you can't solve it as is. So we can't solve a quadratic in standard form. But if I substitute 0 into here, because I have x just this one time inside of those parentheses, now I can solve it. I can add 6 to both sides. 6 is equal to x plus 1 squared. What's the inverse of a square? A square root. So I can use my inverses when I have vertex form, but I can't solve it when it's in standard form. So we're going to have to learn how to convert back and forth among different forms to be able to find those x-intercepts. Okay? You get it? Okay. So again, we're not going into a whole lot of detail, but that is kind of the point here with number 2, and we're going to come back to this next unit. It says consider these two functions. Actually, may do it tomorrow after the understanding check to build better understanding. I'll think about it. But notice it says consider the two functions shown in question 1, identify the form of the function given, and then write the function in the other two forms. Right? We have what in this first form here? Or this first function? Factored form. So what are the other two forms that we're going to want to get? Standard and vertex. We actually have already learned how to go from this to standard form if we go back and look at what Christine did. If I want vertex form, I need to calculate the what? Vertex, right? So I would find the average of the roots. And so we know how to do this. We're going to go into more detail about this. We'll probably do it tomorrow to help build better understanding. But we have about 15 minutes left in class. So what I want to do at this point, okay, by the way, this is activity 4.3. This is the last new skill before the test. It's only going to be like one problem, but it will be on the test. We'll have to do that tomorrow after the understanding check. Because what I want to do right now is I want to give you some time to work on Mathia. So go ahead and get out your iPad. Yeah, no, I'm going to do that while you're doing that.
Yeah, I can go ahead and
Yeah, I appreciate it. Yes, ma'am. Say it again. How many of us are? I mean, we still take the test Friday, so I will record. You should be able to take it then, and then